Kenny, why you didn't do this for your dad class?
What are you talking about?
I said, camera.
What do you mean? Like, why didn't I do the second block? My camera was dead. I forgot to charge it, apparently. So, identifying key features. What do you think I mean by key features of this function, or these linear functions? Could those be important features? Okay, so x-intercepts, y-intercepts, whether the values are positive or negative, yes, or where the values are positive or negative, that's something we could look at.
I'm talking about the line.
What do you mean?
Like, you know, the line going this way.
But it's a trend line, so when it's...
Well, when you say negative and positive, what are you referring to then? It's actually what Cam already mentioned earlier. Positive or negative. What was the term you said just a second ago? That might be important as a feature of a linear function.
Slope.
Right? Positive or negative slope is what you're referring to? Okay. Now, let's back off of just linear features of a linear function, because this is all I've heard so far. Just in general, what are features of a function that we should pay attention to? Of a function, not data, a function. Like if we had a cubic or a quadratic or an exponential.
Like a parent function. Like, you know what I'm saying? Like this, what's all in the parent function? Right?
Not just parent function. If you had that function, what could we think about with that function?
The roots.
Okay, that would fall under x-intercepts. Okay, concavity would be a thing. Alright, so concavity. What else? Now in this, we can't have a vertex. What's the only type of function that has a vertex?
Maximum, minimum, relative.
A quadratic, right? But a relative what? Maximum and minimum, okay? What other features can we look at for a function like this? You know, I'm missing like one of the big ones. There's a pair of them. One starts with a D, one starts with an R.
Oh, domain and range.
Domain and range. Those are kind of important, aren't they? Come on, yeah. Alright, so domain and range. There's two more that we need to think about. It's describing this section of the graph, and then just another one describing this section of the graph, and then another one. Increase and decrease, right? Domain intervals of increase and decrease. Now, I want to go through a couple of these to explain why we're not going to focus on these for linear functions, but I want you to notice, if I talk about domain intervals of increase and decrease, what's the issue when we're talking about a line? That one's just increasing, or a line could just decrease. So are we going to worry about intervals of increase and decrease with lines?
No.
Nope. Domain and range. What do I mean by domain? Hey Hobson, you involved or just chilling? Alright, well if you need to, stand up. It's something to do with the x. So the domain is all my x values, right? So we see all of these x values, or there's x values for every point right here on this graph. But it's going to continue going to the, so what's the lowest x value? Close.
Negative.
Right, to the left, so negative infinity. What's the highest x value? It's going to keep going to the right, isn't it? Now I want to point this out. Is that the same for this positively sloped line? The lowest x is negative infinity, the largest x is positive infinity, right?
Yeah.
Okay. So is that domain ever going to change for a line? No. So we're not going to worry about domain because it's always the same for a line. If it's some other kind of function, we might look at it. What about range? If domain is x, range is y. What's the range going to be? Notice the y value is going to keep going down for forever, and it's going to keep going up for forever. Is that range ever going to change for the line? So, we're not going to worry about it for linear functions because it's always going to be that. What might be the issue with relative max and min for lines?
It's nothing relative about the...
It's got to remember. Well, it's going straight up. So, is there anything that's a relative max or min? No. It never stops increasing and starts to decrease. It never stops decreasing and starts to increase, so we're not going to do relative max and min for lines. What about concavity for lines? It's not a parabola? I mean, that's not a parabola, but it's got concavity. but it's just a straight line, so does it have concavity? No. So I do want to point out, when we get to higher degree polynomials, you will actually have more than one concavity. Like if I draw a line, it's right about there, but if you look to the left, what's the concavity for this cubic? It's concave down. It's down like a frown, right? This section over here would be concave up. So you see how there's two different sets of concavity for that? So we'd have to pay attention to that. But for a line, there is no concavity. So what are the features we're looking at for a line? Those are it. We go with those details. Remember that stuff. Cool. So, some of us need me to stop talking so we can stay awake and do some work. Maybe stand up and show the work. Yeah. So, what we're looking at here, you can, this is on the very front of the page, you can go ahead and turn on your calculators and go to page 1.2 on the calculators. You should have a file that you can open. Don't save, don't save.
I got a little stuff on.
We've done that during enrichment.
I don't know.
But then you don't have time now, you got stuff to do. I guess you are a senior. Grab a phone, move to the back. Chase, come on man, we got stuff to learn today. 1.2 is where you want to be. Guys, if y'all need to stand up so you can't fall asleep, you don't fall asleep, cool, but like we got stuff to learn still. Come on, Cam. Do I need to turn it up hotter so we don't fall asleep? Then you need to stand up. I'll start making myself sweat and make sure we ain't falling asleep. I'm over this. Alright. So, one of the things that we have to do, now we'll point this out, does anyone recognize this task at all? No?
I mean, it look like the, I forgot what it's called, worksheet that we used to, do when we first started.
This is a task that we did at the very beginning of the semester. Okay? So, this is not brand new information. We are redoing this because we are doing the next lesson in this unit, and we need to remember a lot of the background details to be successful with that lesson. So we're going to learn about how to use the zoom feature. Which specific zoom feature are we looking at here? Look through this paragraph. What feature are we looking at? Look at the paragraph. There's one specific zoom feature that we are using. Zoom data, right. So, follow directions, do zoom data on the calculator so you can see the data, help your classmates if you run into any issues. Then, start on this next part. When you look at the data that's on the graph, it's going to match these points in this table. Write a linear function that models this data. Hey Chase, it's hard for you to learn to sleep like that. If you need to stand up, stand up. I'm about to take your desk away. Tip it over. So you have no desk to sit in. So much for active collaboration. It's never the day. Sometimes you just gotta make yourself do it.
What are we supposed to do after the Zoom there?
So notice right here, because this is the Auntie's data set is actually from a previous lesson that we did earlier in the year, but it says write the linear function that models this data here. So you have the data points in this table right here. Write the equation of a line that might represent those data points. Y'all remember that time Chase complained about how hard the test was in the middle of the test and then he slept in class the very next day I taught?
Hey, what my backpack did?
Did you put it back there?
It's right here beside me.
This one over here?
It's a deal for the UN.
They're right. Say again? Go back to Zoom. Which Zoom feature are we supposed to use? We're trying to see data. Zoom data, so use 9. You see the data? Okay. I see a whole bunch of us writing or typing on the calculator, but we shouldn't be typing on the calculator right now. Right now, we should be trying to write the linear function. How are we gonna write a linear function, guys?
In the graph, table.
Okay, so how are you gonna use this table? Okay, this is why we're in small groups, let's actively collaborate. Come on, Chase, for real, I need you to try to learn something. You're leaving Hobson hanging here. Just this top sheet. There's stuff on your calculator that you need for it. Hmm? Yeah, you're good. You're supposed to be on 1.2 right now. That's where this data set is. So group 2, check in with each other, see if anyone needs any help. If you have questions, ask for help.
I forgot it. This supposed to be a slope intercept form.
Okay. So to write out the slope intercept formula of the line, they help you get started. Well, which letter is the slope? Okay. Do you know how to identify or calculate the slope? You just give them the answer, Cam. I'm talking through with them.
Ain't it 55?
You all agree? 55 for the slope?
I don't agree.
You don't agree? Why not?
When you, they get ready to change, it's 50.
Oh, yeah.
So you think the slope is what? 50? Say again? Awesome, look at the table, notice the patterns and relationships. Right? So we get an equation yet?
Y equals 50x.
How could you check to see if that equation is correct? Hey, yeah, graph that function. What should we see if y equals 50x is the right equation? It will be a trend line, so it should go through the what? Does it go through those data points? I know you hadn't even typed that equation all the way in there.
I got mine right.
You got yours?
Mm-hmm.
So I'll look at yours in a second. So Eric, this one's yours. Does anyone see what the issue, what just happened? Oh, there we go. Does anyone see the issue with Eric's?
He put 50. 50, yeah.
So remember,
Even if you do that.
there it is. So that's closer, but, okay, so you're now just starting to rotate things around and move it. So that's actually one of the skills we're about to look at. But that's not necessarily what we have to do here. So you originally put in 50, we need 50x. Chase, is this one yours, I think?
Yeah.
Notice this is the 50x, what's the issue? Or is this an appropriate trend line? It is?
I wouldn't say so.
Why not?
You don't, it's, all the scatter plots are above the trend line.
So, well, so all the data points,
Yeah, they.
right? Notice, is it going through the data points?
No.
No? Is it close?
Yeah.
Yes, and so notice it probably has the same slope, but it's a little off. Cam, what did you put for yours?
Y equals 50x plus 15.
Y equals 50x plus 15. What about that trend line? Yeah? How do we know that this is an appropriate trend line? Goes through all the data points. Now, it looks like some of us need a little bit of a reminder about linear functions. First off, we already said y equals mx plus b, right? That's the slope-intercept form of a line. And that's the equation we're going to want to use today. But we didn't have to struggle with this quite so much. What do we mean by m, or how do we calculate m?
Change divided by change.
You need to hold on to that definition, right? Because we've also done rise divided by run, but we need change in y divided by change in x today. And so I will point out, is it enough to just look at this plus 50 here? Right, that is my change in y, but really I also need to always look at that change in x as well. And so my slope is 50 divided by 1, or 50. So, but what do we mean by b again? Or at least the y value of the y-intercept, which is 15. How can we identify the y-intercept like that?
When the x value is
Right, so Eric, you were missing that earlier, but the x value is 0 right there, so that y-intercept is 15. We need to think through all those details every single time. Hobson, you good? What you working on, bud? Can I help you?
Still.
Okay, cool. Say again, sir? Okay, what operation allows you, well, yes, that works, but what single button can you press to do most of the operations on this calculator? So hit menu. What are you trying to do? Create to go to graph, and you want to graph a function. Type in the equation. Remember we just went through the creation of that equation, 50x plus 15. So, a couple of details I want to point out. Why does the line perfectly match up to the graphed points?
Why did it perfectly match up?
Because the y, like you got a constant rate of two.
Uh-huh,
The x value is two.
that's true. But what I want to point out is, we have a scatter plot over here with a trend line. Does that trend line go through every single data point?
No.
So why, in this case, does the trend line go perfectly through the data points?
The data points the data points do all data points have a slope? Like, well,
The trend line will always have a slope.
I'm saying like the data points, they are, it's constant.
You're close. I kind of. So what kind of function has a constant additive rate of change?
The line.
A line. So the data points are a perfect what? Line.
Yeah,
Are data points always going to be a perfect line?
No.
No. So we just need to recognize here, why does the line perfectly match up to the graph points? Well, because the data points are already a perfect line. But if the data points are not a perfect line, we're never going to be able to get a trend line that perfectly matches up. Okay? So that's important to recognize. Alrighty, we good with that information? Jason, got all that written down? You're just hoping it sticks? Okay. So you'll notice, and I'm leaving this information up there so that Hobson can get this written down, but I want you to notice at the bottom of the page it says most real world data do not perfectly fall in a line or curve. So in the next problems you will need to adjust a line to fit the data as well as possible. This is a part of the next lesson, so we do need to learn from this skill about how to fit the data as well as possible. You will need to practice this graphing transformation feature. So notice you can grab and change the slope. In fact, Eric, I think you were doing this earlier, right? So play around with it. What symbol should you see if you're trying to change the slope?
Yeah, recycling.
It looks like a recycling symbol, right? Okay, and if we want to change the y-intercept, we need to see the that little cross. So use your calculator. Make sure you know how to do that skill. We're not going to spend forever here, but this is something you have to know for the next part of this. All right. So Khalil, You working on it? Dude, you don't even have the file open. Why didn't you open the file? What's you been doing this whole time?
I told you.
You don't know how to work it.
I need to get.
Okay, then ask. I didn't hear you say anything. To get you caught up, I'm just gonna jump to here. So notice how I did the zoom, and I hit zoom data. We'll go automatically just at the data. And then we're trying to put a graph in there, function, and it's 50x plus 15. I'm gonna go check on the other group, but talk to Erik. He's literally already been doing these transformations. How's it going over here with our transformations? Do you remember how to do it? So what do you need to do? No. We've already got a graph. I'm asking you to do the transformations that they're talking about down here. What can you do? I don't know what you're saying. If you don't know how to do something, what can you do? Ask questions. I already see Chase doing it. Talk to him, and then if you still don't understand it, I'll be more than happy to help you. Okay? Talk to him first, though. We gotta learn how to communicate with people.
I'm just over here.
I mean, you're moving that line around, so you're doing something. Erik, did you make sure Khalil knows what he's doing? Okay. So I got somebody, man, they're going all over the place. What are they changing right now? What are they changing? They're changing that slope. Now I want you to slow it down. I believe this might be Chase. Is that correct? Yeah. Okay. So, Chase, slow it down a little bit. Now slowly change it. I want y'all to look at that equation. What is literally changing in that equation? The slope. What's not changing? The y-intercept. What symbol do we see when he grabbed that line? Go back to where you were.
You have to stay down here to move it?
Well, not to move it necessarily, but what symbol do we see when it's changing the slope?
Recycle.
It's not quite recycle, but it does show a rotating symbol, right? Now, Chase is asking, do you have to be down at the bottom? The answer is no. Chase, why don't you move that cursor up to the very top? The top of the line, sorry. Top right. You see how it has that same symbol up there? And so you can change the slope from the top as well, but how are we going to change the y-intercept? Huh? So if you hit escape really quickly, Chase, and then go to the middle of the line, see how we get that little cross symbol to change the y-intercept? Now you can move the line up and down. Notice, is the slope changing at this point? Just the y-intercept. Huh?
He lost the line.
No, it's still there. Looks like he lost it, but he got it. Okay. Okay. Talk with Chase, make sure that you can see how to do it. Khalil, you good with this?
Yeah.
Okay. So you're good with it now? Okay.
We won't let him move this.
Oh, you see how you're really close to the writing right there? You can't have that right there. So what you need to do, hold that, move it off to the side. Now, I think it's also on the top.
Really?
Someone else's. Oh, because yours is still in press to test mode. You need a different animation.
Wait.
See if I did.
Am I seeing it right here? I got time on it, sure.
Actually, Hansi, just sign into a different calculator because this one's in press to test mode, and that's why it wasn't letting you do that. actually, just use that one right there, that's Nemo's. Okay. So, we should be okay moving things around. Hobson, let me know if you still need help in a second once you play around with it on his. Hey guys, thank you. So here's what we're doing. We're about to pick up with the actual first task. This is on the back side of that first paper. So go ahead and flip it over for me, please. Thank you. So, we should hopefully remember this context at least a little bit. Please note, when roads and bridges are built with concrete, builders have to plan for extreme temperature changes because the concrete expands and contracts. What did you say, Erik? Yeah, we've already done this once. But we need to be reminded of these skills so that we can be successful when we move to the next lesson. So, what I told y'all about last time was, have y'all ever driven over a bridge made out of concrete and it feels like the car is like basically shaking? It goes clunk, clunk, clunk every so often. That's because if you look right here, they insert expansion and contraction joints. Because what will happen is when it gets really hot outside, that concrete's going to expand. And if it gets really cold outside, the concrete's going to shrink or contract. Yeah. So what would happen if you had a whole lot of concrete that shrank up? What's going to happen to that concrete or that road? Okay, but there's more issues. There's actual issues that's going to happen if
It's gonna crack.
it's going to crack. It might develop some potholes. It's going to break.
Final destination.
Okay? Yeah, exactly. If you have a bridge that starts to contract, what's going to happen?
It's gonna fall.
That bridge is going to collapse, right? Like these are legitimate issues. Similar thing, if that bridge expands too much, it's going to break the supports that are underneath it and the supports on the edge of the bridge. So that's why they have these joints there. And yeah, we don't want that, right? So we want people to live. Huh? That's mine. So what we're about to look at is some real world data where a construction company created 1 mile of concrete roadway to collect data as the temperature changed during fall, winter, and spring. So I will point out the expansion and contraction is over, I think it was a mile. Yeah, 1 mile of concrete expands this much. And so follow the directions on page 2.2. So you need to go to page 2.2 on the calculator. Right? Zoom to fit the data to your graphing window, at least that's what the directions say. Enter the function f1 of x equals x, and transform the linear function to fit the data as best you can. Once you do your transformation, start answering the questions, recording your model, and answering the questions there. That's what they tell us to do, start. Again, remember you're in small groups. I want y'all to actively collaborate and discuss. But if you're still not getting it after you talk to the people in your groups, let me know. I'll be more than happy to explain. What'd you say, Hobson?
Yeah, working.
It's not working?
What's he talking?
Have you talked to Chase yet, see if he can help you?
I don't know. It's weird.
Have you looked at it yet? Because he grabbed a different calculator.
I showed him. Oh no, it didn't work. Like it didn't even pull up the thing. You said I need to.
Really quick, I want to point something out. What's your y-intercept right now? No, I'm just talking about on his game. What's the y-intercept right now?
What are we doing?
No, it's just 51.2, negative 51.2. What's the lowest y value? If you looked right here, I think it was like a negative 5. Do you think you're going to be able to get that line where you need it to be with that kind of y-intercept?
No.
So I might change my y-intercept first.
But I ain't even clicked it to do no work.
Awesome. You would?
I'm trying, man. I'm trying.
Stand up. Then you ain't trying that hard. Well, you stand up, it'll help you stay awake. Yes, it will. Your body's trying to fall asleep because the blood's not moving. You stand up, you walk around, you will wake up more.
Cause his data points in, you know.
Is he on 2.2?
Yeah.
Cool. Follow the directions, let me see. This is. He never zoomed to it. Right. Oh, you know how I knew that they're there?
I seen it
It's
right
right there,
there.
right? So remember, what we just looked at was that you can zoom. What option under zoom?
It's just I can't because I have a light.
You don't like to?
No, I have that.
There they are, right? And then you have a line up here that you can start to move. Maybe. Okay. Let's get everyone else's time. Now, everyone needs to get their own, but let's look to see.
How you turn that diagonal? Around.
Yeah, talk to Eric while I get this set up. Remember guys, I want you all to talk first, and then I'll be more than happy to show. So, this is Eric's. What do y'all think about Eric's trend line? Man, Hobson, it must feel great to complain all the time.
I'm not technology, man.
What do y'all think about Eric's trend line?
I think he's valid.
You think it's good?
Yeah.
Cam, what do you think? Best trend line.
Oh, yeah,
It's good? What's good about Eric's trend line then?
it's split. You give a bit, good and stuff.
It seems like it's splitting the data pretty well. Does it roughly show us the trend in the data? Yeah, okay. So I would go with that for Eric, but now Eric, did you just do it for him or did you show him what to do? No, that's not gonna help him. I'm about to undo all your work.
All they did was turn straight. I mean diagonal. The line.
Did you get it to here or did Eric get it to there?
I had like that.
Okay, so I want you to look at it, because is this where you were when Eric took over? So this is where you need to teach him, Eric. I want you to look at this right here. Oh, look right here. What's your y-intercept right now?
45.69.
Negative 45.69. What does it look like the y-intercept should be? What does that look like? Look at, there's a number right there.
It won't rotate it.
Negative 5? I'll come and check on yours in a second. I know why you think that. But if your y-intercept is negative 45 and it's supposed to be about negative 5, that's going to make it hard. So transform it, right? So change that so that the y-intercept changes. Make sure he knows how to change it specifically for the y-intercept. Which one's not rotating? Yours?
Yeah.
Okay, so you're running into the same issue that, hold on. Instead of doing it that way, look at what your y-intercept is right now. What is that? But what is the lowest y value in the window right here? That's why. It looks like it's not changing. It is changing the slope. But you're trying to get this to rotate over to here. The only way to change it is to change the y-intercept. So, I was saying, you might want to start scrolling to the left. There you go. So maybe now it'll start to work, okay? Now try rotating it. So, right. You can rotate now. You see how it's rotating